Have you ever wondered why, in an age of space travel and instant global communication, some people believe the Earth is flat? It's a fascinating question, and today we're going to dive deep into one of the most enduring debates of our time. We'll explore the claims, examine the evidence from history and modern science, and try to understand why this idea persists. So let's get started. First, what exactly is the flat Earth theory? Proponents suggest that our world isn't a spinning globe, but a flat, stationary disk. In this model, the North Pole sits at the center, and Antarctica isn't a continent, but a massive ice wall that surrounds the known world, holding in the oceans. One of the most common claims is that the horizon always appears perfectly flat, no matter how high you go. Whether you're at the beach or in a plane, the line where the sky meets the sea looks straight. Flat Earth supporters ask, if we live on a ball, shouldn't we see a curve? Another point is about water. The saying, water finds its own level, is used to argue that the surfaces of oceans and lakes are perfectly flat. This seems to defy the natural behavior of water as we see it in our daily lives. Then there's the evidence from long-distance photography. There are examples online of photographers capturing images of distant cities or landmarks that, according to spherical Earth geometry, should be hidden far below the horizon. These photos are presented as direct proof that curvature doesn't exist. A major pillar of the theory is a deep suspicion of government space agencies like NASA. The argument is that all images and videos of a spherical Earth from space are sophisticated fabrications, computer-generated imagery designed to uphold a global conspiracy. Some also turn to ancient history, pointing to old maps or religious texts that seem to describe a flat, enclosed world. They argue that our ancestors knew the truth, and this knowledge has been suppressed. At its core, the perspective challenges our everyday experience. We don't feel the Earth moving, and when we look around, our world seems flat and stable. So the question is posed, why should we trust complex scientific models over what our own senses tell us? These are the foundational ideas we'll be exploring. But to get the full picture, we need to look back in time, long before NASA even existed. It's easy to think that the idea of a round Earth is a modern concept, something we only learned after launching rockets into space. But the truth is, humans figured it out over 2,000 years ago, using nothing but their minds, simple tools, and careful observation. Let's travel back to ancient Greece. The philosopher Aristotle, living in the 4th century BC, he made a simple but brilliant observation during a lunar eclipse. He reasoned that only one shape casts a circular shadow from any angle, a sphere. If the Earth were a flat disk, its shadow would sometimes appear as a thin line or an oval. Then came Eratosthenes, a Greek mathematician living in Egypt around 240 BC. He conducted one of the most famous experiments in history. But in his own city, Alexandria, to the north, he observed that a stick placed in the ground at the exact same time did cast a shadow. He realized this difference in shadow angles could only happen if the Earth's surface was curved. By measuring the angle of the shadow and knowing the distance between the two cities, he calculated the circumference of the Earth. His result was remarkably close to the measurements we have today. Ancient sailors also had clues. When they watched a ship sail away toward the horizon, they noticed it didn't just get smaller and smaller until it vanished. Instead, it seemed to shrink. The hull would disappear first, followed by the mast, and finally the top of the sail. These observations were made centuries before any modern government or space agency. They weren't based on authority or belief, but on reputable, logical deductions about the world. Fast forwarding to today, the evidence for a spherical Earth is overwhelming and comes from countless independent sources. Modern science doesn't just suggest a round Earth. It relies on it. Take the GPS in your phone or car. The entire global positioning system is a network of satellites orbiting a spherical Earth. for it to calculate your location with pinpoint accuracy. Its software must account for the planet's shape, its rotation, and even Einstein's theory of relativity. If the Earth were flat, GPS simply wouldn't work. Think about air travel. Pilots don't fly in straight lines over a flat map. They fly along great circle routes, which are the shortest paths between 2 points on a sphere. A flight from Sydney to Santiago, Chile, for example, curves far south towards Antarctica, a route that makes no sense on a flat map but is the most direct path on a globe. Airlines save millions in fuel by following these curved paths. Another powerful piece of evidence is something you can see for yourself. The stars in the night sky change depending on your location. If you live in the northern hemisphere, you can see Polaris, the North Star. This phenomenon is only possible if you are moving across the surface of a sphere. It's not just NASA, the European Space Agency, Russia's Roscosmos, Japan's JAXA, and now private companies like SpaceX have all independently sent people and satellites into space. Astronauts and cosmonauts from different nations and political systems have all seen the same thing: a beautiful blue spherical planet. For a flat Earth conspiracy to be real, all these competing countries and private entities would have to be secretly collaborating for decades. Without a single leak, the evidence from modern science isn't from a single source. It's a web of interconnected, verifiable facts from fields as diverse as physics, geology, and engineering. So, with all this evidence, why do the common flat Earth questions persist? Let's address them head on. First, why does the Earth feel and look flat? It's a matter of scale. The Earth is enormous. You need to be at a very high altitude, like in a high-altitude balloon or a rocket, to start seeing the curve clearly. What about the feeling of motion? Why don't we feel the Earth spinning at over 1,000 kilometers per hour? The same reason you don't feel your speed when you're on an airplane flying smoothly. We don't feel constant velocity. We only feel acceleration or deceleration. You and me is moving along with it, so it feels perfectly still. And the water argument? It's true that water finds its level, but that level is determined by gravity. Gravity pulls everything toward the center of mass. On a spherical planet, the center of mass is at the very core. So water isn't forming a flat plane in space. It's being pulled equally from all directions toward the center, creating a curved surface that conforms to the shape of the globe. The surface of a vast ocean is, in fact, curved. So, if the scientific evidence is so strong, why does this debate still exist? The modern flat Earth movement is often about more than just science. For many, it's a symptom of a deeper distrust in institutions, governments, media, and scientific bodies. It can represent a desire to think for oneself and not just accept what authority figures say. It's a form of ultimate skepticism. And let's be clear, questioning things is the heart of the scientific method. Every great discovery began with someone questioning the established view. Science welcomes skepticism, but a claim must be supported by evidence that can be tested, verified, and reproduced by others. When a theory like the flat Earth is consistently contradicted by observable reality, we have to follow the evidence. The goal isn't just to question, but to find the answer that best fits the facts. So where does that leave us? We've looked at ancient observations, modern scientific proofs, and the everyday technologies that depend on around Earth. From the shadow on the moon to the GPS in our hands, the evidence from independent sources across centuries and cultures all points to one undeniable conclusion. Our planet is a sphere. This isn't a matter of belief, opinion, or trusting a single authority. It's a conclusion built on consistent, repeatable, and verifiable evidence. Encouraging curiosity and questioning the world around us is vital. But true understanding comes when that curiosity is guided by evidence. The shape of our world is more than just a piece of trivia. It's a testament to the power of human observation and reason. and a reminder that we all share a home on this vast, beautiful, and deeply connected globe. Thanks for watching. If you found this exploration interesting, please give this video a like and subscribe for more deep dives into fascinating topics. See you next time.